Welcome to our presentation on the Slipform rig build. This is for the high risk review at the 2 Finsbury Avenue project. The high risk review was jointly carried out with Sir Robert McAlpine management. The development of risk assessments were done based on this joint risk review, as well as the development of the methodology and the inspection and test plan. The program was reviewed as far as off-site, on-site assembly, when both the slipforms were going to start and complete and being struck. Obviously there was 2, so we had to make sure that there was resource available, sufficient slab cast, material laydown areas. So the program was really important that we understood that they functioned and that the program was realizable. Part of what we had to consider were neighbours living next door, so our working hours were really restricted. We had to make sure that our concreting hours were such that we had enough to cast, wash down, complete and be off site for 6 o'clock. So with that in mind, we targeted 3:30 as the last concrete to be placed on the job. The development of the inspection test plan for this Slipforms was a bit more intense than most and had a lot more considerations. We have not had a Raptor crane or any crane sited on top of the Slipform before, where the Slipform was the foundations, and also part of that was at the end of the slipforming operations, dismounting of the crane onto core walls. All needs a lot of very, very detailed inspections and test plans, which were developed with our other company and the designing of it. Multiple people had to come together to get this inspection test plan to be bulletproof. Due to the project being a top-down type of construction, there was no slabs for the internal cells in many places because the shafts wouldn't have been cast below. We had to come up with a plan on which cells to install decks and sole plates, how we were going to actually suspend those. Notably, there was structural blinding down below which the transfer beams were cast onto. While excavating below, any false work put inside there would have been trapped or possibly damaged when the blinding is knocked up from down below. So we had to make sure we planned correctly which cells had to have a different type of false work with fixtures to the walls. So there was a lot of planning works to actually even get kicked off before we started the slipform. The Raptor crane was another consideration we had to look at, in that its weight coming down on structural blinding would not have worked. So a sandwich slab was cast within the cell, which took part of the framing system that would then be picked up around the crane, enabling the slipform to later pick up the whole crane. An overview of the 3 different levels of a slipform. This is just to show those people who are not familiar that there are 3 decks: top deck, which is actually a loading deck, the working deck where most of the people work, and a trailing deck for making good of any blemishes. This diagram particularly denotes the working deck area, which is where most of the trades work, which will be putting in reinforcement, putting the concrete in, door frames, any other casting items normally takes place on this deck. Below you can see the components that make up the support of the deck. All the internal cells were actually made off-site and brought into the project on lorries. Lift assessments were carried out for all of them. The long lengths of external shutters were made up and lengths that are manageable. So there was a lot of collaboration with the Slipform company that we hired from, and making sure that each of the components are manufactured to the right standards, sizes, and a a visit to the yard was done to check on that they're made correctly as well. All the external decks were fabricated on site. All the timber items were installed on the project, so that was the only part that could not be done as far as at the yard prefabbed. The top deck, although it looks slightly different to the diagram on the left, is all done on site. That is, once the working deck is completed, it is done in situ as well. There are lots of openings, hatches, etc. So generally this does not get made off site. Deck consists mainly of H20 ladder beams which sit on top of the steel girders supplied by the Slipform company. Thereafter we ply. Most times we double ply for the top, just to make sure the punch resistance from the reinforcement, etc. on the top deck, which is also the loading deck. The facade elements for the Slipform are prefabricated off-site. They sit on a steel framework which sits on the handrails already installed, as you can see on the left hand side, bottom of the slide. They are then connected to the Slipform, bolted, and all gaps sealed up so nothing can fall between the top deck and the working deck. As the Slipform rises, first lifts of concrete, we can start installing the trailing deck, which consists of hanger frames, and then we install the timbers to stand on, walk, and also the internal toe boards. We also put rubbers strips in there, which protects from any debris falling down, which is not quite as per this diagram. It's the next step in the assembly. This slide depicts where the edge protection is installed. The little black spot to the bottom within the elongated triangle you can see is the rubber strip which goes up against the wall and stops small items from being able to fall past the Slipform rig. As we get started with slipforming, the top deck will need to be loaded out with a certain amount of reinforcement. As you can see on the picture to the side, it's fed through the mesh down to the working deck, where it is then spliced and tied by another steel fixer on that level down below. The diagram you can see there is the loadout plan, is what we're allowed to load on this rig without overloading any of the jacking systems. You can see the areas in yellow, those are not to be loaded out. Central one will be the tower crane, then all your corners are no loading zones, simply just walkways. As per the previous slide, you can see to the left there's a grating, which reinforcement is then passed through down to below. You can see in the central diagram, that'll be the bar passed down to the fixer below to splice. Then on the right hand side of this diagram, you can see the laces being installed. They're stored on top of the yokes, but they have to be fed in underneath the actual bracings. So you've got a zone below of approximately 800 millimeters in which to fix all your laces. We next